Hai Zik.
Hello Azrin. Yep.
Sekejap, ada apa-apa ke I kena like buat in particular selain ambil attendance?
Ambil attendance and then you moderate the room je lah.
Okay, alright.
Itu je, simple je. Wait, I have to make you a host lah. Because I have to leave. I have to go to campus later.
Tak apa.
Okay. Okay, you now the host. So I think you can control just display the thesis and pre-thesis punya attendance.
Sekejap, nak display tu kat mana? Dekat chat Boleh Kat sini?
Oh, kejap. Dekat chat boleh juga. Wait. No, dekat. Actually, you have to share the QR code.
Okay. So kena share dekat WhatsApp group tu ke?
Better dekat the room lah, because kalau dekat WhatsApp group, siapa yang tak datang pun boleh ni.
Sekejap. I try sekarang.
Kalau tak dapat, I can screenshot the QR code lah, tapi takut tak clear.
Okay, tapi I rasa you boleh copy kan? Kalau you right click dekat situ, you boleh copy, lepas tu you paste je.
Ya ke? I'm not sure, tak pasti ya.
Sebab I punya attendance ni, I ada pre-thesis je. I tak ada yang thesis.
Oh, tak ada Oh, okay. Jangan. In that case, I just wait. I try to screenshot.
Tak, you dah buka kan? Apa QR code tu? You right click kat QR code tu, you save image or something. I think that is clearer.
Oh, you save image. Yes. Okay, betul. Sekejap Stop. This one is pre-thesis. Okay. I think I can WhatsApp you lah kan? The QR code. Boleh kan? Okay. Okay, the students are coming in. Okay, Sam. Okay, Dr. Intan also here.
Dia dah WhatsApp
Dia WhatsApp.
Assalamualaikum, good morning.
Salam.
Intan.
Selamat pagi.
Okay tak, Azrin?
Kejap, I try.
Kalau tak dapat, I think I can share first lah. I can share my screen first, but then I have to make a run lah. Kalau slow sangat lah. Sekejap. I think I have to share. Okay, students, I think you can scan the QR code for attendance. The left one is actually thesis. The right one is pre-thesis as usual. How to remove this thing?
Okay. I got it in my WhatsApp. Jadi I share my screen again lah.
Okay. You can share at the end of the lecture as well.
Betul. Dr. Intan dah ready ke? Nak memberi bahan.
InsyaAllah boleh.
InsyaAllah I pun interested juga ni. Okay. Tengok how many students dah. Is it you dah start record
Yep. because I made the setting to automatically record.
Okay. Right.
Yeah.
Fantastic.
I think we can start at 9:35, right?
Okay.
Student can take the attendance. I think
Yeah,
around
okay.
9:33 I have to stop sharing, and then I have to make a run to the campus.
No problem. Izik, yang you share dekat WhatsApp tu kan, yang first tu pre-thesis atau thesis punya?
I think the first one is the thesis.
Thesis, okay, alright. I nak letak dalam PowerPoint.
Okay, Azrin, I think you can take control from here.
Okay, all right. Thank you, Cik.
Okay.
Okay, for a couple of minutes, friends to join, um, and then we will start at 9:05 lah. All right, everyone. I think we can start now. Today we have Dr. Tunku Intan Suraya Tunku Aziz to give some input on active versus, or rather passive versus active building systems and the return of investment. So this is a very important topic for us, especially as we are looking into the social cultural aspect of our design studios this semester. Also applicable to the TC students as well. So perhaps I would then now not take too much time and actually give the floor to Dr. Tengku Intan Suraya. So Dr. Intan, the floor is yours.
Okay, Assalamualaikum and good morning, everyone. Okay, I will start my lecture by sharing my screen. Okay, so today we will talk on passive building system versus active building system and the return on investment. Okay, so the content of this topic is on passive building system, active building system, future of passive and active, and also on the maintenance. Okay. Return on investment is a ratio between net income and investment. A high ROI means the cost invested is favorable to the investment. As a performance measure, ROI is used to evaluate the efficiency of an investment or to compare the efficiencies of several different investments. So the market forces driving change includes the energy cost reduction by the first one is the regulatory demands, which includes the state, local, and federal. And then second one is the customer demands. For example, we can follow the guidelines by the lead and cascade. And also the third one is the market forces or discipline of the marketplaces. Okay. So there are factors of energy efficiency. The first one is the active energy conservation, the passive energy conservation, quality of operations and maintenance, and also the last one is on the demand management. So all of these factors will become or will affect the energy efficiency of our building design. Okay. So into the first subtopic, which is the passive building system. What is passive building system? Okay, so passive building design use the natural movement of heat and air and the other physical principles operating with little or no mechanical assistance. Okay, they are usually fairly simple system with no switches or controls. Passive system work best in areas where there is a fairly large difference between daytime and nighttime temperatures. And then it is depending on the location and the structure. Many of these systems do not completely replace traditional system, but can be effective supplement to the heating, cooling, light, and water needs of a structure. So this diagram is an example of a passive design. Okay, so for example, we apply on the solar orientation of the building, and then you can put high performance windows, and then high insulation. You can also apply balanced ventilation with heat recovery and also having an airtight construction. Okay, so the key building envelope issues includes, for example, here, water, such as rainwater system, wastewater treatment, and more. Then we can have air such as natural ventilation, cross ventilation, and more, and also a vapor such as evaporative cooling, and thermal such as direct solar gain and indirect solar gain. So this is example of a stack effect, okay, where you can apply a cooling system, natural cooling system to your building, okay. Okay, there are advantages of passive building system. The first one is cost only once. Okay, then second one, it is fixed costs. Third one, it is predictable streams of benefits, and fourth one requires small maintenance or not at all. Okay, so basically, it is a very affordable and also will use less cost to build this passive system to your building. Okay, so usually you will get a return of 60 to 80% energy cost saving. Then you can have fresh, clean air all through all the years, and then you can consistently have consistent temperatures and also 50% less total energy consumption. Okay. But there are also disadvantages of this passive building design. Okay, the first one, you might have to upfront your own costs, and then second one is on the essential fixed, and third one, it cannot be easily upgraded, and fourth one is the thermal bridging issues. Okay, so on active building system, what is active building system? Okay, uh, Okay, active building was a thermal that being used to refer a building system that supports the wider grid network by intelligently integrating renewable energy technologies for heat, power, and transport. Okay, so this is an example of an active building system that you can apply to your building. Okay, this usually it is a support system that you want. Okay, so the active building system use principally mechanical systems such as a mechanical electricity in ventilation, lighting, occupancy, and etc. It needs to monitoring by responsible party, and it can manage its own energy performance. And it also combines range of integrated renewable energy technologies and work together as one system to reach its purpose, generate and store and release heat and electricity. Okay. There are advantages of this active building system. Firstly, it is high performance. And then it has advanced analytic and real-time performance monitoring. It also has maintenance alerts via alarm and also have high cool factor. Okay, but it also have disadvantages. For example, here we have uh, high cost, which is on the maintenance cost. Okay, and then you need to have software intense required periodic updates. And then there are security issues, which is addressable nodes. And also without proper maintenance, it will deteriorate quickly. So the future of a passive and active system. Okay. Okay, the first one, adaptive and fuzzy logic. Okay, so unpredictable system. It is multiple values to be processed through the same variables. Okay, this is studied by the mathematical equation by Scott. Okay, then there are key takeaway. For example, in Boolean, they have a glass of hot water, okay, or the glass of cold water. But in fuzzy logic, they say that the warm water is neither hot or cold. Okay, so this is the Boolean fuzzy logic system. Okay, this is what it might be um, if the active system in future can be like. Okay, so we can have in this kind of system where it might be in hot or cold water. Okay, so this figure shows the system of fuzzy logic adaptive for the future active system. Okay, and then we might have an enthalpy energy recovery exchanges. Okay, so this is on the recovery wheel. Okay, a circular honeycomb matrix of heat absorbing material, which is slowly rotated within the supply and exhaust air streams of an air handling system. Okay, so the key takeaway of this system is a cooler air is humidified, and you will get a warmer air that will be dehumidified. Okay, so the system will look like this in this diagram. Okay, so it is like a heat recovery ventilator or an energy enthalpy recovery ventilator. Okay, so the third one, we can have an occupancy sensors. Okay, so it's like an electric device where it can detect the presence of a person. Okay, the key takeaway, it is automatically deactivated the light so that the energy can be conserved. Okay, so this is an example of a occupancy sensor detector. Okay, and then we can have in future a geothermal heat pumps. Okay, it comes from the geothermal plant. Okay, the systems transfer heat by pumping water or refrigerant, a special type of fluid, through pipes just below the Earth's surface, where the temperature is a constant of 50 to 60 degree Fahrenheit. So the system can run in a reverse. Okay. So this is the diagram of a geothermal heat pump where you can use during the cold weather and also during the summer. Okay, can be reversed either way. Okay, so it works underground of your building. Okay, then there is a liquid disease air conditioning where it has open absorption cycle. Okay, the ambient air, which has to be dehumidified, enters the absorber and comes in touch with a liquid desiccant. And then the warmer the surrounding air, the higher it is condensing temperature. In this study, the condensing temperature for the system is assumed to be 50 degrees Celsius. Okay, so here we can see the heat source, or for example, a solar panel. Okay, then it will produce or give a supply of heat to the wet air or the regenerator. Okay, so you will get the decent storage. Okay, and then the last one here, you will have the dry air, where the ambient air will be absorbed to this regenerator. So you will get a balanced heat inside your building. Okay, so the next system is a micro-channel heat exchangers. Okay, for example, we have a louver as a solid way. Okay, it is a generating series of thin boundary layers to interrupt the airflow. Okay, it will lead to improvement in the heat transfer. The circulation mixes cool and hot air, leading to enhancing the heat transfer. So the best part of this system is the air passes between externally while the refrigerant flows internally. Okay, so this is example of the louvers type. Okay, it will exchange the heat of the hot and cold. Okay, so in future, we might have this kind of passive system. For example, a stagnant power, where you can have no maintenance, control, or even moving parts. For example, a louvers, this kind of louvers. Okay, then you can also build around 4 external envelope, the water, vapor, thermal, and air. Okay. However, the reality of both systems we have here, it is, for example, if we are using the active system. So in reality, it is interdependencies or too dependent. Okay, it needs to be controlled or it will be too complicated. Okay, and then it will create potential problems in security. But if you are using a passive system, it is a science evolution in building that improves your performance of the building, but it also will give better materials like applying sprays or liquid to the building, and also it can qualify installers and designers. Okay. In terms of maintenance on the passive and active system, okay, the data point overload, okay, the amount of input into a system exceeds its processing capacity. So consequently, when information overload occurs, it is likely that a reduction in decision quality will occur. Okay, the information overload, why it matters and how it combat it. Okay. Then the reactive and proactive of the maintenance reality here. The reactive maintenance will be repairing performed after machinery has failed, and the maintenance focuses on repairing equipment to as close to normal operating condition as possible. And the proactive maintenance, it is identifying and correcting the source of underlying facility conditions, which is to avoid unplanned downtime equipment failure. Okay, so the overrides of the system, it is interrupted as a system to intake the authority, such as from online to manual. Okay, this is the building automation system, where we apply the active and passive system to the building. Okay, so it's basically that we are normal in using it. Okay, so the objective of having this building automation system, the first one is improving the occupant comfort. So when we are designing a building, the important thing that we need to consider in the end is to have or to achieve the comfort for our occupants. Okay, so it includes the thermal or the daylightings. Okay, so we need to, at the end, to fulfill their comfort. Okay, so the second one objective is in the efficient operation of the building system. Okay, we need something that is efficient. Okay, so that we can reduce the cost of operating the whole building system. Okay, and then we need to have the reduction in energy consumption. Okay, this is also important because we don't want to overusing the electricity to our building. Okay, then we need to reduce operating and maintenance costs. Okay, increase security, historically performance, documentations, and remote access control operation, and also improve life cycle of the equipment and related utilities. So overall, the whole system here is to help our building to operate in a lower cost, but also efficient in giving comfort and a sustainable green building design in future. Okay, so there are maintenance challenge, okay, that you can have through this BESS system. Okay, the first one is the troubleshooting. Okay, it is a complex system that depends on another system to be operated by tracing and correcting faults in mechanical or electronic system. So this BESS system needs someone that can operate it, because later we might occur this troubleshooting problems, and then there will be some technical training and also system training. So it is quite a complicated system, but you can still apply for your building operation. Okay, so in future, okay, this BESS system, you can have maintenance moving forward towards it, where it has the transition to stabilize the occupancy. It is expected occupancy that the building will have. Okay. Then there will be a pump on the pay. Okay, the rise up of the payment for the maintenance staff to provide a good service. And then on the challenges industry, in proposal of the building should require the maintenance saving idea, and the client shall willing to pay for it. Okay. Some of the benefits of regular maintenance are, okay, first one is the system stay current, and then it will increase energy efficiency and reduce energy costs, and then reduce the overall cost. And final one is increased life of the system. Okay, so in conclusion, the owner should invest well in passive energy system, maximize the usage of passive system, simplify and have efficient use on active system, and then need to balance maintenance capabilities and reduce the maintenance cost of complex BESS. Hence, this will help to achieve maximized ROI from their investment. So throughout the passive and active design, active system, so means that at the early stage of our building design strategies, okay, we need to consider on having this passive energy system at the first place in order for you to avoid by having to apply the active system, because what we have here, it seems that the active building system still will need to we need to still pay a lot, okay, to apply this active system in terms of the long run of the system itself, because we need to pay for the maintenance and also for the staff who manage it. Okay, so that is why the passive energy system is the best to be applied for your building, so that you can maximize the ROI in future. Okay, so I think that's all. Thank you.
Okay, thank you, Dr. Intan. Okay, students, do you have any questions? You can either type in the chat or you can also just like unmute yourself and ask directly.
Dr. Intan,
Yes.
this sort of active application, is it already
Yeah.
implemented in Malaysia?
Oh, I think not yet, because this is a study conducted on the overseas. Okay, because most of the system is already applied in the overseas. Okay, so they come up with the study in collecting the data. So that is why they can conclude that by having a passive building system is much more giving on a better ROI on the investment.
Okay, thank you.
Okay, welcome.
Okay, any other questions? I quite like how yesterday we had a tech Fendi who shared his experience in designing social housing, and then I think a student asked, with the issues that we have in like PPR and places like that now, is it an issue of design? Like, is it our fault as designers, or is it like, it's the inhabitants' fault that they are living in such condition now? And he basically answered that the I mean, at the end of the day, it's about maintenance, right? So the maintenance culture is we don't really have that in this country. So, and also like people don't want to pay for the maintenance. They don't want to pay for the maintenance cost, and which is why then the maintenance couldn't be done, even though I think most of the design of the these PPRs and social housing is already like using passive systems. So I think this is also a very important message for the students. I mean, if we have something passive and we have an issue of maintenance, maintaining something which is already like should be easy to maintain, what more if we were to introduce this active system, right, in this social in our housing typology. Yeah, so I quite like that there is a link between what the message of Architect Fandi yesterday and your own lecture today, which basically really shows which system is better. All right, are there any more questions from the students? No? Okay, all right. Dr. Intan, do you have any takeaway message for the students?
I think from what we have go through in overall the design process and so on. Okay, actually the passive system, we can see there's a lot being applied in Malaysia too, but there might be some newly invented that we haven't yet explored. Okay, I mean our own designers and so on, but I think in future our designers should take part in trying a new types of materials, for example, okay, whichever that it can lead towards a passive system, because we understand here after they have studied it, then it seems like passive design is much more preferable, okay, to in order as a long run that we won't have to face with maintenance issues and so on. So the first stage, which is the design stage, is the most important to every designers need to really think of it, because if the issues occurred after your design has been completed, that is why the active design or the active system comes in. Okay, because the active system is something that you need to force or you need to add on, okay, on the failure or whatever lacking on your design issues. That is why at the first place, it is encouraged that you give a thorough thought on your own design, whichever what you want for your building. For example, you want a low energy saving kind of building. So what passive system that you can apply? So there are actually a lot, Okay, you can also try explore on the materials. Okay, I can see that many research have go through this kind of an eco-friendly kind of a material. Okay, so there are a lot more for our designers to try and explore rather than we just focus on what is outside what we have currently, but we need to try explore more. Okay, I think that's all from me.
Okay, thank you, Dr. Intan. That's very
Okay.
clear your message, design properly in the beginning. Okay. All right. Thank you so much, Dr. Intan, for making the time to be with us this morning. For the students, I will display again the attendance QR codes for the next 5 minutes. So if you haven't, you can just scan it. Yeah. That's it, I guess, and then I think with my own students, I'll see you at like 10:30. Okay. All right. Thank you, everybody. Thank you, Dr. Intan. See you in a couple of weeks' time in KL. All right. Thank you. Bye. Okay, I assume everybody has scanned the attendance. So I'm going to close this room now, okay?